Hello, welcome guys. So today we'll be discussing two problems on real analysis, and one of my students asked, and the problems are really good. So I think it's quite interesting to do the problems and discuss the problems. Quite really shows the important aspects of problem solving. So do real analysis questions for you, and they will be helpful for you to prepare an IIT JAM and ISI MStat both. So let's dive into the problems. Two problems. I don't know what does this question 12 and 13 means, but yeah, I mean somewhere it belongs. So let's dive into the questions without further ado. So let's try to understand. Okay, so we have a limit to find, and 1 plus 1 by n plus 1 by 1, like this harmonic sum by log this plus this. I mean this is there. Okay, so when you see this problem, how do you approach this problem, guys? If you see this problem, guys, the idea is that you should know about this result. That, I mean, this is a very natural result. Okay, so summation of 1 by n is divergent, you know that, but at which rate, at order of which? So it is in the order of log n. So this is like really interesting result, and with more practice it comes. So we will gonna prove this. Okay, it really increases the log n rate. So we will use the inequality. This inequality is really important. Let's see. This inequality, let me mark over here. I hope all of you can see this inequality over here. And yes, so this inequality means that summation 1 by k is less than 1 plus this and this. So how does this come? However, so it's come from a geometrical form. Okay, so remember this result. So if you do 1 by x, let's say it's 1, starts from 1, and then it's 2, then it's 3. Let me do a little bit more. Y 2, and then 3, and then 4. If you see, let's calculate this. So we'll calculate in two different ways. In this red way, 5, and this goes on 6, and we will calculate in two different ways. And let's say in this green way, let's say in this green way, okay, like this. In two different ways we will count. Okay, let's see what really we are getting over here. Observe that we are getting the following result. Observe the very following. See, so this integration, this area under the curve is what? Integration 1 to say n. Let's say this is n. Okay, 1 by x dx, or let's say dt, since this dt over here. Let's say 1 by t dt. It's being actually bounded by, it's bounded by two stuff. What are the two stuffs? Understand this very carefully. The upper green stuff, let me write in green, is what? See, it's, what is this height? This is 1 by x curve graph, right? So this height is what? This height is same as 1 1. This height is same as 1 by 2. Okay, so therefore what is this length? The area. The area is, length height is 1 and 1. So therefore I think this is not like to scale. So but yeah, this area is 1. Okay, and this area is what? Half. This area is 1/3. This area is 1/4. This area is 1/5. To 6, its integration, its summation k from 1 to n minus 1, 1 by k. Also the greater than part, that is the red part. See, the red part is less than that curve, right? So this is greater than that curve. So let's do the red part now. Red part is what? Half. It starts from k from 2 to n. Okay, it starts from k from 2 to n. So this is the result we got over here. So let's try to understand this. Let's try to see this where it's going. Yeah. So therefore we got the following result, that integration, this integration 1 upon 1 by dt by t is less than summation of 1 by k, k from 1 to n minus 1, greater than summation of 1 by k, k from 2 to n. Okay, and we got that, therefore we got the following, that, so let's try to bound now. We'll change this from bounding k from 1 to n. Okay, k from 1 to n. We will try to bound this. Try to understand this. If we add 1 to k over here, if we add n over here, what do we get? So if you try to get a lower bound to this, try to understand, to get a lower bound to n, it will be integration 1 by n plus 1 dt by t, right? Just try to understand this. Want to get this, so it's 1 by n. So if you put n over here, it will be n plus 1. So that's what how we get lower bound. Now to get the upper bound, see what we need to just add k is equal to 1. Okay, so therefore that means what? We need to add k is equal to 1 on both sides, so it will be at 1 plus 1 by integration 1 by n dt by t. I hope I understood this. Therefore, this is the result what we have got over here. Oops. Just let me check. Where did it go? Just let me check. हाँ आ गया. Yes, I hope it's clear now. I hope you can see it clearly. Yes. So what we will doing now is this, that now we have done this result, so we have got this result over here. So let's now try to solve this and show that actually this harmonic sum is actually behaving like log n. So what we are seeing over here, this, if you just integrate it, it get that summation, this harmonic sum is log n plus 1 plus and less than 1 plus log n. And if you divide by log n, you get that log n plus 1 by log n is by log n is this. Okay, observe that as n goes to infinity, this goes to 1, this goes to 1, therefore this goes to 1. Perfect. So therefore what we get over here, we get that this thing goes to 1. Okay, what about this thing now? This thing we will calculate over here. It's very easy. So let's try to understand it. So we will observe that pi is greater than e, because pi is 3 point something and e is 2 point something. Okay, and 2 by pi is less than 1. 3 by pi is less than 1. So therefore let's take pi out, pi to the power n out. So pi to the power n into 1 plus e by pi whole to the power n. इसका whole to the power 1 by n करूंगा तो ये कट जाएगा, so ये this will be there. So now observe as n tends to infinity, these are the form what? This is goes to 0 because this is less than 1, so e to the e by pi whole to the power n will be less than 0, like going towards 0. Okay, and therefore we get that this goes to 1 and therefore this goes to 0, so it's e to the power 1 to the power 0 form. Now 1 to the power 0 form is 1, right? 1 to the power 0 form is 1, so therefore this goes to pi. So therefore it goes to 1 by pi. This goes to 1 by pi. I hope all of you understood this now. And this is what we are getting over here. Okay, so let's move on to the next problem. The next problem is another real analysis calculus problem, and I love this problem because this problem was sort of the problem I was asked in my BStat interview. Okay, so it's really understanding in details. Okay, so a possible value b for which the equation x to the power 4 plus bx cube plus 1 is equal to 0 has no real root is what? So I'll give an algorithm to how to give the proof. So the idea is that whenever you are doing like this, try to understand, you have to plot the graph for which possible value. So I try to plot the graph which is more than what is needed in the problem, but let's understand. So essentially, if one has a real root, okay, that means it's a minimum value. This is the idea. If one has a real root, fx has a real root, that means fx ka minimum is less than equal to 0, minimum value. Okay, fx continuous because it comes from intermediate Hull property. If it's continuous and it's less than 0 and there are some other paths will be greater than 0, this implies, okay, and therefore what does it imply? Therefore we have to find the minimum value. That's the idea. So let's differentiate it. F dash x, f4x cube plus 3bx square, and you do it. You see that 2 points are there, x is equal to 0 and x is equal to minus 3 by b by 4. Okay, pardon if I've done calculation mistakes, and if you do double dash you get that it's 12x square plus 6bx, and if you do this at these 2 points you get f double dash is 0 and f double dash of minus 3b by 4 is greater than 0. Okay, it's equal to 9b square by 4 aa raha hai. So therefore it means that it's a minimum. So therefore at that point the minimum always happens. Okay, and try to understand the x to the 4 का graph कैसा होगा. 0 में in point of inflection होगा, Okay, what is point of inflection? It's like if you do excess cube graph na, it happens like this. Also excess cube ka 0 mein f dash is 0, but it happens like this, and it happens that if f dash x 0 and f double dash x is 0, but f triple dash x is not equal to 0. So you can understand from here it's not equal to 0 if you like, because b is not equal to is 0 over here. So therefore it will look like this. And also x to the power 4 is positive, so as x tends to minus infinity, it goes to infinity, and as x tends to infinity, it goes to infinity. So it comes from this side. Try to understand the graph. This is very important for your understanding, because whether whatever you study, this graph's understanding is really important. And now at this, there's a point of inflection, and the minimum is occurring as x naught. This, let's call it x naught. Its minimum is occurring. So what is we have to see? We have to see that at this point of value, the real root. I mean, at this point of value, the minimum it's no real root means that must be greater than 0. Okay, f of that point, f of x naught. So I have calculated f of x naught over here. So f of x naught equal to f of minus 3 by 4, and we have got this very after long calculations, not long, but yeah, it's got that 1 minus 27 b to the power 4 by 256. Now if fx 0 if x naught is greater than 0 implies no real root, right? So I have just equated this, and we have got that this is a condition. So now you put in these values of b over here, guys, and you can get from here that, oops, what is happening? It's not moving. Let's see. Yeah, and you can put in the values over here, and you can check sort of for which value it is sort of there. But understand from there it's around say 9. So it's less than 10, right? So you can say b to the power 4 is less than 10 and greater than 10. So therefore it's sort of, we can understand that from here that b to the power 4 is less than 10. It sort of implies that b is greater than minus 10, the fourth root of 10, and greater than less than minus fourth root of 10. So it cannot be, I mean, it is less than 2. Okay, I mean, it's very less than 2. Maybe it's, yeah, so this is not possible, never, because it's greater than minus 2, less than minus 2. This is not possible. 1.5 and minus 1.5. Okay, so sorry, this is 2.5. This is also not possible, therefore this is only the possible. So you see, so I have not calculated even, but yeah, I have got it. So this is actually close to minus 1 point something, and this is close to 1 point something. So yeah, so you can say this. So this is a beautiful problem, and it sort of involves how to draw the function. So I think it's really important to know these results and ideas so that you can use this to your fullest. Okay, so these are the two beautiful problems that I have for you, and thanks Anindya for giving us these problems, and I'm glad to share the solutions with you. Okay, thank you, and see you in the next video, guys, with better problems, new problems, and interesting ideas. And I hope you understand this, and I hope you enjoy this, and till then, stay tuned and stay blessed. And by the way, don't go away, please, for subscribe and to our channel if you like it, and share with your friends. Also, we have done IIT JAM MS ka preparation tips in our videos. Please see that. Let us know in your comments what extra content you need from us. I will give it to you. Okay, all the best, good night, and see you in the next video. Bye bye.